Good evening, sir. Myself Vishal Sinha, a student of Coach Behar Government Engineering College. My roll number 34900323014, and today from the Department of ECE. And today I'm going to discuss my presentation on the topic of modulation from the chapter Analog Communication. Analog modulation, an overview. Analog modulation is a cornerstone of communication system, enabling the efficient transmission of information over various mediums. Modulation involves imposing information onto a carrier wave, adapting it for more effective propagation. In an analog communication system, modulation is crucial for overcoming limitations such as antenna size and signal interference. Common techniques like amplitude modulation, frequency modulation, and phase modulation have shaped the landscape and analog communication with early radio broadcasting serving as prime example of its transformative impact. The need for modulation. Antenna size. Transmitting baseband signals directly is impractical due to the relation between antenna size and frequency. For instance, an audio signal at 20 Hz requires a colossal of 3750 km antenna, rendering it infeasible. Modulation addresses this issue by employing higher frequency waves. For instance, a 1 mHz carries necessitates a manageable 75-meter antenna, making signal transmission viable and efficient. Talking about signal propagation characteristics vary across different frequencies, impacting the efficiency of transmission. Modulation allows signals to be transmitted at frequencies that propagates more efficiently, overcoming limitation associated with baseband transmission. Moreover, it adds into overcoming interference and facilitates channel allocation, optimizing the use of available bandwidth, ensuring reliable communication in crowded spectacle environments. Amplitude modulation are three types. Amplitude variation. Amplitude modulation involves varying the amplitude of the carrier wave in accordance with the message signal. Its mathematical representation is given by STAC 1 plus KMT cos 2 to the power 5 FCT, where AC is the carrier amplitude, K is the amplitude modulation index, and MT is the message signal, and FC is the carrier frequency. Talking about modulation index K plays a crucial role in AM, with overmodulation avoiding being paramount to prevent signal distortion. Ensuring K is greater or equal to 1 guarantees that the amplitude of the modulated signal remains within acceptable limits, preserving signal integrity and preventing unwanted artifacts. Simple implementation. And AM offers a relatively simple implementation, making it attractive option for various communication system. However, it is internally susceptible to noise, which can degrade signal quality. Despite its simplicity, the vulnerability to noise remains a significant drawback in an environment with high levels of electromagnetic interference. Frequency modulation. Frequency variations. Frequency modulation entails varying the frequency of the carrier wave in accordance with the message signal. Mathematically, Fn can be represented as St, which is equal to AC cos 2 pi FCT plus 2 pi kf mt dt, where AC is the carrier amplitude, kf is the frequency sensitivity, and mt is the message signal, and fc is the carrier frequency. Improved noise immunity. Compared to amplitude modulation, frequency modulation offers improved noise immunity. Frequency modulation inherent robustness against noise makes it preferred, ensuring reliable communication even in the presence of interference. Talking about bandwidth consideration, which is the point number 2. Bandwidth considerations are paramount in FM systems. Carson's rule provides a practical estimate of the bandwidth required for FM transmission, given by BW is equal to 2 pi f plus FM, where delta f is the peak frequency deviation and FM is the maximum message frequency. Phase modulation. Phase variation. Phase modulation involves varying the phase of the carrier wave in accordance with the message signal. Mathematically, PM can be represented as ST AC is cos 2 pi FCT plus KPM to the power T, where AC is the carrier amplitude, KP is the phase sensitivity, MT is the message signal, and FC is the carrier frequency. Relationship between FN and PM. There exists a close relationship between FN and PM. Specifically, phase modulation of the integral MT is equivalent to the frequency modulation, highlighting the inherent connection between these two modulation techniques. Bandwidth consideration. Phase modulation exhibits similar bandwidth consideration to frequency modulation. Efficient utilization of bandwidth remains crucial in PM system, with techniques such as pre-emphasis and de-emphasis ability to optimize signal transmission and reception, maximum spectral efficiency. AM demodulation techniques. There are two techniques: envelope detection and synchronous detection. Envelope detection is a simple and cost-effective technique for AM demodulation. It involves using a diode detector circuit to extract the envelope of the modulated signal. Proper selection of the time constant is essential for accurate envelope following. Synchronous detection requires coherent carrier recovery for AM demodulation. It implies a block diagram to illustrate the principle of operation, emphasizing the need for precise synchronization between the carrier signal and the demodulation process. FM demodulation technique. Frequency discriminator. The frequency discriminator is a component of some receiver that converts the frequency variation into amplitude variation. This is done using circuits like Foster, series discriminator, and ratio detector. Block diagram explain their operations. Phase lock loop PLL. A phase lock loop is a feedback control system widely used in FM demodulation for its robustness. It compares the phase of two signals and adjusts the output to keep the phases match. Application of analog modulation: AM radio broadcasting, FM radio broadcasting, and aircraft communication. Let us understand all three. AM radio broadcasting utilizes amplitude modulation for long range transmission, leveraging its relative simplicity, operating in the frequency range of 530 kHz to 1700 kHz. AM radio broadcasts have been staple of audio transmission, delivering news, music, and entertainment to listeners across vast distance. FM radio broadcasting employs frequency modulation to deliver high fidelity audio with reduced susceptibility to noise, with a frequency allowance range from 88 MHz to 108 MHz. FM radio broadcasts offer enhanced audio quality compared to AM, making it ideal for music and other high fidelity content. Aircraft communication. AM is employed in aircraft communication for airband ratio. Its simplicity and reliability make it suitable for critical communication between pilots and air traffic control, ensuring safe and efficient air travel operations. AMI, FN, and LCD modulation technique. Advantages and disadvantages. AM simple long range, FM noise resistant high fidelity, PM similar to FM. Disadvantages of all three: successibility, noise, lower bandwidth, higher bandwidth, more complex, used in specific communication systems. Conclusion: there is a fundamental role. Analog modulation remains a fundamental aspect of communication system, providing essential technique for signal transmission and reception. Their different characters AM, FM, and PM offer distinct characters, allows tailored to specific application, enabling engineering to select the most appropriate modulation scheme based on system requirement. Digital modulation technique have largely suspended analog in many areas, yet analog modulation retains relevance in niche application and hybrid system. Thank you so much, sir, for giving us the opportunity to present this presentation. I am very highly obliged of your opportunity.